Hello. Now we'll be solving question number 3 from phase 1 book, and chapter is forces and the laws of motion. So let's read the question. A body of mass m is capped on a rough horizontal surface. A friction coefficient is given as mu, and a person is trying to pull the body by applying a horizontal force, but the body is not moving. The force by the surface on the body is F, where value of F needed to calculate. Now the F is what? F is force by the surface on the body. The critical aspect in this equation is force by the surface on the body is F. What is this force by the surface on the body? That force is known as contact force. We have discussed that in the theory part. Now, when it comes to contact, whenever there is a contact, there will be a contact force. The cause behind the contact force is deformation. So with contact comes the deformation. And once the deformation is coming, reformative force will become. Okay. And that force is known as the contact force. The direction of contact force is not known. Magnitude is also not known. To study the contact force, we divide the contact force into two components. One component will be perpendicular to contacting surface, which is known as normal reaction. And the second contact force is parallel to the contacting surface, is known as friction. So normal reaction and friction, they are nothing but the two components of a single contact force. And these two are connected because these are ultimately components. Okay. So example is asking about the contact. So since this one and this one, they are mutually perpendicular, this contact force, two components of this contact force, then resultant of these two will be the contact force. So value of F will be under root of normal reaction square plus friction square. Ultimately, we have to calculate normal reaction in this question and the friction in this question. From there, we will calculate the F. So first of all, we have to understand what is this question. Okay. This question, directly they are asking F, but they want to know and the F. So let's calculate it. And to calculate, we make the FBD. In that way, we'll show all the forces, and as a rule, we first show the field force. Field force is mg, which is acting downward, and there's only one field force. After the field force, we show the contact forces. And to show the contact force, we count the contact. So you see, this is one contact, and this is another contact. There are two contacts here. So the contact here will give rise to two components, which is normal reaction upward, section backward. And the contact here will give the rise to the external force. Let's call it F1. And according to question, the body is not moving, so acceleration is 0. So let's balance it. So if I balance along the horizontal, I'll get F1 is equals to small f. And if I balance along the vertical, I'll get N is equals to mg. So normal reaction is coming out to be mg, and the friction is, the friction is coming out to be the F1. Now thing is, in this case, it's the static friction ultimately. And as far as the static friction is concerned, we might get two different values. So this friction I can replace by mu times of. So these two components of contact force, they are connected by this formula. Friction is equals to mu times of. This mu is a variable until it becomes constant. So I'll replace this, and normal reaction value also I'll put from here. So I'll get F1 as mu g, which is smallest. So let's calculate the contact force F. The formula was n square, which is mg square, plus f square, which is mu mg square. So mg square I'll take common, which will be mg under root 1 plus mu square. That's the value we are getting. So the contact force is coming out to be mg under root 1 plus mu square. As I said, this mu is a variable. The value of mu will vary from 0 to mu k, quadratic section. So what we can do, the maximum value of mu can be mu k. So this force will always be less than or equals to mg under root 1 plus mu k square, and will be more than the least value will be 0. So that is mg. I get the range depending upon the value of mu. So this contact force will always be less than this, and this contact force will always be greater than mg. This is a very nice question where we are learning more about the contact force. In this question, examiner try to confuse you with the contact force. But when examiner was asking about the contact force, indirectly examiner wanted to know about the friction and the normal action only, which we generally calculate using the simple method called as query. Okay. So I hope you understood this question. So as you can see, this option, this is your third option, C option. C option is the right option. So I hope you understood this. Okay. Thank you.